squared is equal to the initial velocity squared plus 2as. Now, to get the final equation, we are going to substitute the value of v. We are going to substitute the value of v in that our equation. So I'll just write it out again because I've, everywhere is jam-packed already. So remember, we have this formula: S is equal to U plus V over 2, times T. Now, and then remember our first equation, which is V is equal to U plus, that should be plus, U plus AT. So now I want to make V V is already the subject, right? So I'm just going to substitute V, as U plus AT in this our equation again. It's going to give me the final equation. So we have X is equal to U plus, but V is now U plus AT, so I replace it to U plus AT all over 2. Then the whole numerator is multiplied by T, don't forget. So let me just continue. We have that X is equal to, distributing T to everything, we have T times U, that's the first term. Let me just be showing this so you can understand what's going on. So T times this U is giving me UT. So we have UT plus T times another U is giving me UT again, plus T times that will giving me AT squared, right? That's T times T now. Then everything all over 2. Now we have that X is equal to UT plus UT is giving me 2UT plus AT squared, all divided by 2. Now we can go ahead and distribute the denominator 2. So we have that X is equal to 2UT over 2 plus AT squared over 2. So that 2 can cancel. Now I'll use a red for that, making it more, let me use red. So we have 2 can cancel 2. Then finally, I'll just use another color. Finally, our equation becomes that X is equal to UT plus, now AT squared divided by 2, we can just write it as 1 over 2 AT squared. This is the way you're going to see it, most often in your textbook. So that's why I'm writing like that. You can also write it as AT squared over 2, but 1 times AT squared is still AT squared, right? So this is the other equation you must know, that the distance S for any body that is uniformly accelerated is equal to UT plus half AT squared. So I'll just highlight it again to maintain my pattern. So that's the fourth equation. Now this is the fourth equation. So this is how to derive all the equations of motion. So I hope the steps are quite easy. So you can always rewind this video because it's always important for you to understand these formulas. So I'm just going to write all of them together at the end. So look at where we started. We started from distance is equal to U plus V over 2 times T. Alright, this is the average velocity times time. And then we said that V is equal to U plus AT. Now, this is from the formula of acceleration. We made V the subject of the formula. So this is the second equation. We now have derived that V squared is equal to U squared plus 2AS. This is the third equation. And then the fourth one, we have that S is equal to UT plus half AT squared. This is the fourth equation. Now you need to know these formulas. Please know these formulas. And one thing you must know is that these formulas are when the body accelerating is accelerating in one dimension. What do I mean by that? It means that the body is either going up or coming down. In this case, this is one dimension in the vertical, vertical direction basically. So this is vertical one dimensional, right? So the body is either going up or going down, or the body is going towards the right or towards the left, one dimension. So this is horizontal. So when the body is going horizontally, and accelerating. This is for the horizontal acceleration, all these formulas we have. But what if the body is going vertically? Now, lucky for us, it's still the same formula, just that we're going to change some things. Now, let me show you. Now, if a body is going horizontally, just as I've drawn, you know that this distance, horizontal distance, we'll call it S, right? That's the distance. But now, if it's going up, it's still a distance is covering, but we just call the distance height this time. So we just denote it as h. So for this first one, this is for the first formula. If we want to get the horizontal equivalent, or rather the vertical equivalent of it, we're going to replace s with h. So I'm just going to write it in red. H is equal to u plus v over 2 times time. So that's the first formula in the vertical direction. This formula, this other one, I think I'll just make room for that. So I'll write it side by side. That will be better. Now you understand what I mean already. So replace s with h. That's what I mean basically. So let's write this in the vertical. This one is going to imply, we write as v is equal to u plus, now acceleration in the horizontal, we just denote it with a, but acceleration in the vertical direction is going to be g, right? Because that's acceleration due to gravity. We denote it as g, so we're going to replace it as gt. Now another thing I would like to add to this my equation is plus or minus, all right? Because acceleration is a vector quantity, and then if the body under consideration is going against, now gravity is a downward force, that means it's always going to be negative, so negative g. So if this body under consideration is going against gravity, let's say that we have a ball and we throw the ball upward, so you see that it's going against gravity, so therefore the speed will be what? Decreasing, because gravity wants to push it down, so the speed will be decreasing. So in this case, we're going to use our gravity as minus, so work with minus. But if the ball is here and is falling down, it's falling in the same direction as gravity. So when the sign of, or rather when the body is going the negative and acceleration is negative, negative will cancel. That means the body will be speeding up, so we're going to use positive for acceleration due to gravity. So please, you need to take note of this. When the body is going the same direction with acceleration due to gravity, we use positive, but when it's going opposite direction, we use negative. So that's the reason for my plus or minus there. For the next equation, it's going to be v squared is equal to u squared plus 2, acceleration due to gravity now is g, s is h. Again, plus or minus, which I've already explained the reason for this. Then finally, s is something as h, which is equal to ut plus or minus again half, acceleration now is gt squared. So you see that side by side we have the relationship among the two is that they are all one dimension, just that the ones with s and a are direction in the horizontal plane, while the ones with h and g are direction in the vertical. So right, so it's either going up or down, s and a is going right or left. So that's it. Very simple. Very simple. Now finally, because I'm going to solve examples in the next part of this video, so this video will not be overly long. But the last thing I want to say before I call it a day today is that there are some things you need to take note of. What you take note of is when a body starts from rest. So when the body under consideration was it started from rest. Rest means it was not moving initially. So when at the initial time of considering the motion, the body was at rest, we say that the initial velocity is 0, right? Since it was not moving initially. When a body comes to rest, so note two things. This one is starts from rest, initial velocity is 0, comes to rest, then final velocity is 0. Comes to rest means the body was moving with a speed, and then it was decreasing in speed until the point it became 0. That means it stopped moving. That means the final velocity have become 0. All right, take note of this. Now, how is it going to affect these formulas? You know that, for instance, let me just use the last formula for example, this formula. Just highlight the formula I'm using, because most of the textbooks they also make reference to this. So I'll just use this formula and do it, and then that will be it for today. So let me use another color. When this body starts from rest, you see that this first formula will not be h is equal to initial velocity will be 0 since it starts from rest, right? Plus or minus half gt squared. Now anything times 0 is 0, so the whole of this will cancel out. We will now have a formula that says h is equal to half gt squared. Now I'm not putting plus or minus, but you know it's there already. I just want to put it that way. So I'm going to have this formula now. So when do we use this formula? We use this formula anytime the body starts from rest. So initial velocity is 0. So that will be the formula I'm going to use. And in this formula also, this one for instance, when the body comes to rest, then you know that the final velocity v is going to be 0. So please, one of the things you need to take note of when solving questions on uniformly accelerated motion is that you need to be very careful with that word comes to rest or starts from rest. So if you take note of these things, then the question should be relatively easy. So that is it for today. You can click on the description of this video to see the second part of this video, because when we begin to use these formulas to now solve actual problems, that's where we're going to have a better feel of what's going on. So click on that description and then you see the second part of this video, and do watch that. Share with your friends. God bless you.